Let's determine the lifting capacity of a balloon of our own making. For example, consider a balloon that has a radius of 1 meter. The volume of a 1 meter balloon can be computed by looking up the volume formula for a sphere, which is the volume V equals 4/3 times pi times the radius cubed. When we plug in the radius r equal to 1 meter, we get the volume V equals approximately 4.2 cubic meters. Let's assume we're close to the Earth's surface at sea level and at a temperature of 15 degrees Celsius. We can look up the air density here as 1.225 kilograms per cubic meter. If we plug this value into our equation for the weight of air, we get that the weight of air, W air, is equal to 1.225 times 4.2 times 9.81, which is equal to 50.47 newtons of force, which can lift 5.15 kilograms or 11.3 pounds. Keep in mind, that's the buoyancy force. The actual net lifting force that the balloon experiences is the difference between the buoyancy force and the total weight of the balloon, its contents, and its payload. For example, let's fill the balloon with helium gas, which is lighter than air. Helium has a density 7 times lighter than air. The weight of helium for the volume of the balloon is 7 newtons, meaning it weighs about 0.7 kilograms or 1.6 pounds. Thus, if we take the mass that can support our buoyancy force being 11.3 pounds and we subtract 1.6 pounds of helium, that leaves approximately 9.7 pounds for the rest of the balloon materials and any additional payload it is expected to carry. Interestingly, we don't need to fill a balloon with a substance like helium to get it to float. It also floats using hot air to create a hot air balloon. When air is heated, its molecules acquire more kinetic energy, meaning they twist, vibrate, and travel at faster speeds. This also means that the molecules will naturally tend to space themselves out further, meaning that the air density decreases. This lower air density for hot air means that the displaced balloon volume will be lighter than the ambient air.